Okay, so I'm I'm running on now. Yeah, let's go back to where I left off before. Is it? Yep. So I think this is okay. So I think last time, just a moment ago, I was in this file chunk response, right? So I probably won't go into much detail on like the client side, like how it reads the data from the server and like this kind of logic where the clients require no more client master interaction until cat information expire or a file is reopened. Like so, probably it has like probably it's like a wait. Just want to say, can I do this? Not data class. So probably like I have what is that? It's a data class like this, and it has some I don't know file maybe like file name something and something and then like uh no like probably like file um what oh no file workspace so probably like file name um something and like going to be the method John server address like god this is the John server address is probably is it like I don't know is it like um which it should contain like the main I would say the main chunk and then the um like the replicas maybe like maybe replicas like is like list of replicas which is like uh I don't know is it probably sorted by the geographic location probably I don't know yeah okay let's do this more detail on the chunk size chunk size is okay all right so chunk size is one of the key design parameter yeah we have chosen 64 megabyte which is like much larger than typical file system block sizes which is 64 sorry typical file system block sizes is like 4 kilobytes so it's like order of magnitude bigger understandable I mean each chunk replica is stored as a plain Linux file in a chunk server and is extended only as needed. Um, each chunk replica is stored. What do you mean chunk replica? I mean, oh, okay, chunk replica means that the copy of the files. Okay, so blah blah blah. Where is the chunk server? Do I have the chunk server? Yeah, master of chunk. So I think a chunk could be. Oh, sorry. I think a chunk server could like stores. I think it's like distributed randomly or not randomly, but like a chunk server could store. Uh, I think like list of main file um like main files, which is main chunks, which is like a list of stuff that where in this particular server stores the main chunk of a chunk of a chunk of a file. So, and then there's also probably like a replica chunk where I I think like probably it's stored in the different metadata, or it could be like storing the same stuff, or it could be like, or it could be like one self like files probably, and then I don't know, each file is like, it has a property. Its main, like 1 or 0, right? 1 or 0. Its main chunk. I don't know. I think both could be viable option. And then blah 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 longs is extended unless needed. Lazy space allocation. Avoid wasting space due to internal fragmentation. Perhaps the greatest object against such a large chunk size. I have no idea what is. Yeah, I know lazy space allocation, but for what? Extended only as needed. Do you mean like it's not really allocating the entire like lazy space allocation? So I'm thinking like, okay, I have to store this file which has this size, but it is lazy as a sense that okay, I'm going to send this chunk which is like 64 megabytes, but like I'm going to send it like, I don't know, like depending on the bandwidth of course, but like sending for every like 1 megabyte for example, and like just creating the space as needed, like as it writes, not really like allocating 64 megabytes in the beginning and like putting it there like, as the file comes. Yeah, that's my understanding. uh A large chunk size offers several important advantages. First, it reduces client need to interact with the master because reads and writes on the same chunk require only one initial request to master for chunk location information. The reduction is especially significant for a workload because applications mostly read and write large files sequentially. Even for small random reads, the client can comfortably cache all the chunk location information for a multi-terabyte working set. For even for small random read, the client can comfortably cache all channel location information. So you mean like each client also doing this? This is not as bad. I mean, like for example, so for example, cache the location of the channel server. Yeah, this is technically like cache, but like imagine if the each basically because like each chunk size is like 64 megabyte, and like say it is stored in one chunk server. Let's call chunk server CS, and 2 and 3 replicas, right? So this is let's say that it's just like, I don't know, like 8 bytes, I know what's the address of this, 32 bytes, probably less than this, but 32 bytes times 4, which is like, oh, where's it at? 32 bytes, which should be like 100 bytes, right? And then this is just the name string. So the key is like, say, another 32 bytes. Like the key is like 32 bytes, so it's like it's going to be 32 160, right? 160. So in total it's like 160 bytes for 1 terabyte. Okay, for 64 megabytes. So if you want to like multi terabytes, then just yeah, this is times 10 is like, maybe this one times 1.5, which is 1 gigabyte, right? Oh, times 1.5, I know, 1 times 15, right? Times 15 times 10 is this, times 15 is, yeah, so times 15 is like 1 megabyte, 1 gigabyte, and then times 1000, which is, hey, wait, times 1000, which is like 1 terabyte, and multi-terabyte means like say 4 terabytes. So let's say I'm too lazy to calculate this, so this is calculator. Bytes times. Wait, what? That's oh, okay. So yeah, so basically you need 9.6 megabytes for storing wait for storing 4 terabytes of data sets, right? Wait, so for example, 64 megabytes. See, it's like 4 terabytes, right? So if you want to, oh wait, so let me save like explanation makes sense. 32 bytes string, how long? 32 byte string. It's ASCII. It's like 32 character, which is maybe like still okay for like for address DNS. Hopefully it's not that long. If it's like an IP address or it's like a DNS version, I don't think it's going to be like 32 character. And the key file, I don't know the keys. Is it like John handle? Um is it like uh is it like what else? A pure string, or is it like UUID of it? I don't know like what is exactly John handle. But yeah, let's say that it is 32 bytes. It's like just sort the metadata. It's like just less than 10 megabyte, which is that's why it is like super small. Right, so multi-terabyte working set, which is okay. Second, since on one chunk, a client will not perform many operations on given chunk. We can reduce network overhead by keeping a persistent TCP connection to chunk server over an extended period of time. Third, it reduces the size of metadata stored on master. What do you mean? Yeah, I mean like because similarly, the metadata could be like in similar size as I show here, the metadata on the master. So yeah, the size, like I mean like if you want to like half of this number, you need like make it the one chunk uh is 128 gigabyte. But yeah, that's I think this is small enough. But like if you want to like split it into two, make it smaller chunk, then I think it's still reasonable. The metadata is still reasonable in size. So okay. On the other hand, a lot chunks size, even with lazy space allocation, has its disadvantages. Small size consists of a small number of chunks, perhaps just one. The chunk server store of those chunks may become a hotspot if many clients are accessing the same file. In practice, hotspots have not been a major issue because our application mostly read chunk files sequentially. However, hotspot developed when GFS was first used by HQ system. So an suitable is with GFS as a file single file and then start hundreds of machines at a time. A huge chunk server during this executable was uploaded by hundreds of simultaneous requests. We fixed this problem by storing sub-executable with a higher production factor and by making a batch queue system stagger application time. Yeah, so okay, so this is like yeah, I think it makes sense. And like this one is like in this situation why cannot control C. Okay, this one is like If someone wants to improve this paper, then they can do this. Oh, duplication factor. So maybe like in the master, or maybe like the file channel response. Like maybe if there's like replication factor. Right? So I have to hide this, by the way. Right. Oh, anyway. Okay, this is the metadata, which is the master. Which is should be this one. Okay, let's go to dive into this. Master store three types of method: the file, the chunk namespaces, and the mapping from file. The file. Wait, the file is like the actual file address. Like, okay, let's create like a class here. Like, meta class metadata. Metadata. Words in actual or the actual it contains the where's the file should be string, and then the chunk namespaces. I have no idea. A chunk namespaces, which is it be like list of string, and then list of string, like, and then what it, and then the mapping from files to chunk. Basically this one, this file name. Yeah, this is basically what I'm saying. Like the list of chunk server, like chunk location, like the chunk location. Mapping from chunk location is just like, right, mapping from files to chunk. Wait a minute. Moving from file to chunk. So it should be like this though. It should be like the key here. The key is no, it's like wrong. The key is file and the chunk is like the key here, like this. Yeah, maybe the file is not necessarily the file name. Maybe it could be like a hash of it, a hash of the file name, so that it's like unique enough. What file it is? All right, so I have no idea what chunk is. The first two types. Wait, all metadata. Oh, all metadata is kept in master memory. Guys, I like this. This is like in the more dictionary. The first two types, namespaces and file to chunk mapping, also kept persistent by locking mutation to an operation log stored on the master local disk and repeated to machines. Wait, so all metadata kept in memory. The first two types, namespaces and file to chunk mapping. Okay, so file to chunk mapping, this one is replicated to this one is replicated. This one is still in one. It's just like while third-party metadata. I mean, like, it's not necessary to be like this, but file to chunk mapping and basis. What is the first one? The first one is the file. What is the file? Is it the file name? Or what is namespaces? This is. Wait, I'm still streaming up. To okay, so most local design application on remote machine. Okay, so wait, sorry. So sorry. So probably like self. They have local log, which is I know it's like string. It's basically like a path, basically like file path local. Yeah, maybe like it's up, maybe somewhere like app slash I don't know what is that. It could be like db.sqlite. Actually, it can do it can like that, yeah. Right? And replicate it to remote machine. Basically, I would say replicator is like replicator. It doesn't state that remote machine. Okay, so this is remote machine. So replicas, master replicas, which I don't know. It hasn't stated any like specific onto this. So let's just assume that this is like a file server, and yeah, what is it? So let's just assume that this is a file server, and this is just like a remote file server, and like a periodically I don't know, every 5 minutes or something, it backs up the SQLite, the local logs, which is I think still reasonable. Like well, yeah, maybe you want to have like some proper mechanism that each changes or each file is new addition, log it, log it to the local logs, and like make the copy of the replicas, which is I think I don't know, it could be like the remote database write or something. Maybe it could be like SQL, like a remote API. I don't know. It could be. Yep. And remote file server or DP that copies the operation, the local operation. So it doesn't really mention anything about like replicated, like what is exactly being replicated? Is it the file, the operation itself, or the operation itself, or the operation log? Say to an operation log, and replicated. What's the what's being replicated? Is it the operation log, or is it the logging, the mutation? Like oh well, like semantically it should be like the logging mutation, but technically speaking you can do both. You can do either way, or you can do, yeah, you can do either way. Like replicated the operation log stored on locally to remote machine also makes sense. Like people do that. They ship the write ahead logs of their Postgres or any RDBMS to S3. It's like quite common things actually. So either way, it works. The master does not store chunk location information persistently. Okay, this is new thing. Instead, it asks its chunk server about its chunk, right? At master startup. Wait. it asks each chunk server about its chunks at master startup, and whenever a chunk server joins the cluster. Okay, so the client does not store location persistently. Okay, so the master also has like self dot chunks server location, which is like I would say list. I would say list probably, like, oh no, it's like locations, and us, it's chunk. Okay, so it's kind of like no, so sorry, so you can technically do this like when you start up like div start out like this, it's going to ask like for, oh no, wait, itself it asks chunk server, but it's chunk master. Oh, chunk location information. Okay, so chunk location information. So if I understand correctly, so it asks a chunk server. So technically speaking, the master could just restart it, because it cannot, it's kind of like assume that the chunk server already up and running, and then the master just like you can be restarted and it's fine. Master startup, I thought like it's going to be the master is like something that should be there forever, persisted until the end of the day, and like the chance server is like something that could spawn, dies, and that can come and go. But it seems like it is not, and whenever a chance server join the cluster, yeah, this one makes sense. Like whenever chance joins the cluster, chunk location information. Chunk location information is just like a chunk and its location information, and so like every time, okay, chunk server join, how does it know like if the chunk server is actually like completely new machine, or is it like like something that's just being restarted and it persisted like its previous state? Actually, yeah, quite confusing this. Quite confusing, but it's quite unclear what's actually happening. But it asks chunks about its chunks. So basically, the startup will probe the chunk, right? So generally speaking, the master knows where is the chunk server location. So I assume that it is there, somehow persisted, but it doesn't say. It does not say that the chunk namespace, it does not store the chunk server location. So I was thinking like, okay, for a startup, like on startup, like for chunk server in self dot like chunk server location, like do probe, like probing every chunk server, and like, hey, what is like asking, hey, what chunks available on your machine, like probing everything, and like just storing like the information here, like info, like storing like the mapping, and then like storing that self the store the updates, like I don't know, mapping, and like this. But seems like, yeah, this is quite reasonable. Like, I don't know. I mean, like, from this explanation, it looks like it is like this, right? And I don't know. I don't know. But yeah, seems like it is. But it's like, no, this is like raising a question. What if the chunk restarted? Then if because it just mentioned that the chunk server location is persisted. So maybe there's a DNS service that can give this list of chunk server location as startup, and then only after that it can do this. Uh, like call get all chunks server servers from, I don't know, from DNS service from this or something. I don't know. Yeah, it could be. Okay, that's her. The second, the what is that? The 2 point, the next. Oh, what is this? Why is it? It's not going. Can you go? Okay. Alright, so since metadata is stored in memory, master operations are fast. Alright. Furthermore, it's easy and efficient for the master to periodically scan through its entire state in background. This periodic scanning is to implement chunk garbage collection, re-replication, and the presence of chunk server fail, chunk server. Oh my god, what's this? Chunk server failures and chunk migration to balance the load and the disk space usage across chunk server. Okay, that's nice. So, I mean, like, periodic scanning. I mean, like, what? I think even if it is being stored in local, like not necessarily in memory, doing this is not really that heavy. I mean, say that it is like any access from the disk, like from the local log store, which I assume it is like it should be stored in some data structure that that's easy to access, like I don't know, SQL or maybe like key value store or anything. I think that should be like still fast enough. I don't know why it has to be mentioned that because it is in memory, it's fast. But anyway, so let's say that I have background process which is I don't know, running on a spirit thread that drugs trading like I don't know, a function to garbage collection, DC function, and then replicate replicate the representation failures. Oh, so it also need to check chunk server heartbeat, I would say, or failures, what it called, and then rebalancing and like doing everything within the thread. I don't know. Yeah, this is obviously not how the syntax works, but yeah, you can think of it like this. Blah blah blah. Okay. One potential concern for this memory approach is that number of chunk is the number of chunk, and hence the capacity of the whole system is limited by how much memory the master has. This is not a serious limitation in practice. The master maintains less than 60 Oh, look at this. 64 bytes of metadata for each 64 chunks, which is like less than what my estimate, which is 160. This one 160 bytes, like half of my estimate should be. So technically, it should be like 5 megabytes for 4 tera, which is like 1 megabyte for 1 terabytes. Which is, I mean, like for big server like master server, it could be the memory could be like I don't know, maybe 200 megabytes. Sorry, 200 gigabytes or something. So yeah, it's true that it's not really an issue, not an issue at all, right? Most chunks are full because most files contain many chunks. Most chunks are full. Is this referring to the chunk server or the chunk, like the actual file chunk? Because this is full. This is very confusing. I think it means chunk server, and this is like chunk namespaces is the DNS, the DNS name or something. Yeah, it's quite confusing. Like most file contains many chunk and only the last of which may be partially filled. Yeah, so if your file is not in the complete division of 64 megabytes, like in the complete multiplied of the 64 megabytes, then the last chunk is like going to be partial filled. That's right. Similarly, the file namespace new term file namespace data typically require less than 64 bytes per file. File namespace data typically requires 64 bytes per file. So this is the key, because it stores the file names compactly using prefix compression. Okay, I know what prefix compression is. I don't know how is it being stored. I think, yeah. If necessary to support even larger file system, the cost of adding extra memory to master is a small price to pay for simplicity, reliability, performance, and flexibility we gain by storing the metadata in memory. Yeah, it's true. I mean, it's true, but like, even if they want to put this into like database or anything, I don't know. I think I underestimate like the amount of data that they have, obviously. Yeah, I think so. I think like I underestimate the size of their metadata, obviously. But yeah, I personally wouldn't do that. Like storing something very important in the fully in memory, like. But yeah, I mean it's Google. And actually was okay, so the thing that I don't understand is that um file namespace. What is file namespace? Is it going to be the key of this file mapping? Or is it this, or is it going to be something else? Okay, anyway, let's move on. So the chunk location. Master does not keep a persistent record of which some server have a replica of a given chunk. Wait, so it does not know where's the replica of given chunk? Okay, it simply pulls chunk server for the information at startup. Yeah, the master can keep itself up to date thereafter because it controls all chunk placement and monitors transfer status with a regular heartbeat message. Yeah, that's quite common, but wait, so controls all the chunk placement, but not the replica. Which chunk server have a replica of a given chunk? So this is not correct. I mean, oh, okay, this is correct. I mean, yeah, it's just like where's the main, right? So the master have no idea where is the replica. Hmm. Does not keep a persistent record of which chunk server um have a replica of given chunk. Right, so it just keep the main chunk server, right? Okay. It's chunk server replica. It's simply post transfer for that information as sort of wait. Oh, okay, sorry. So actually, yeah. So the chunk server is actually being persisted, right? Chunk location is in fact being stored. Yeah, this is also stored in persistent store. All right. Okay, right. So yep, that's pretty good. And so yeah, it pulls out from persistent store and then put it on the memory, and then chunk location. I don't think this is necessary, but yeah. Okay. Wait. Why is it coming back? The first sec. The master updated. Okay, so on the startup, like this one, it's like probe the what chunk okay, what chunks of what chunks replica available on your machine. I see. So wait, I still wonder, like, is it going to probe its files on a given chunk? Probably not. Probably not probing its files, but it is like I don't know, like a startup. Oh, okay. Chunk response. Oh yeah, probably it's like that class. Class master to chunk server startup probe I would say response to the request is quite straightforward, probably just like even without payload. And basically, the response would be like this: chunk list file to chunk, or maybe like just chunk. It's probably like the abstraction at the chunk server is chunk, not file. Chunk list, and then it's going to be like it's going to be list of file chunk response. Yep, and like it's going to just send the bulk of this. I don't know how big it's going to be, but seems like it's quite big. No, it's not that big. Like one for 4 terabytes, this is just less than 5 megabytes. Sorry, this is actually 60. Well, yeah, just say it is very small. I mean, you can paginate it obviously, but it's server to server communication. It's to be fast. Alright, heartbeat message quite common. Okay, just basically probing, hey, are you still there? If it's not, then I don't know, mark you as died and moves some of your replicas to other replica. We initially attempted to keep trunk location information persistently. Wait, at the master. Wait. I thought they did persistently at the master. Wait, trunk location does not keep persistent record of chunk cipher. Which chunk cipher have a replica of it? Wait, sorry. The chunk does not keep a persistent record of which chunk cipher have a replica of given chunk. So it's just not which chunk cipher have a replica of given chunk. Does not keep a persistent record of which chunk cipher have a replica of given chunk. Like it just does not keep the replica, right? But it still keep the master. We initially attempted to keep chunk location information persistently at the master. Okay, but decided that if it was too much simpler to request the data from chunk cipher at start. Chunk location information persistently at the master. I mean, I think chunk location information is the whole information. Like for each chunk, where is the master and like where is all the replica. But simpler to request the data from chunk server at start and periodically thereafter. This eliminates the problem of keeping the master and chunk server in sync, as chunk server join and leave cluster, change name, failed restart, and so on. Okay, that's in cluster with hundreds of servers, this event happens all too often. Another way to understand the design decision is to realize that a chunk server has a final word over what chunks it does or does not have on its own disk. There is no point in trying to maintain a consistent view of this information on the master because errors on a chunk server may cause chunks to vanish spontaneously. They must go bad, this might go bad or be disabled, and an operator may rename a chunk server. Okay. Okay, so wait. Okay, so I start to understand this. No, this is not stored in the persistent store, right? It's not stored, and basically this should be true. This should be like the namespace, like probe all IPs in this. I don't know, chance server join in the certain namespace or something, and like, okay, it's there. Just get that information from this list of DNS service, and I don't know, start with the DNS like chance server dot GFS blah blah blah, and get everything from there, right? And then from each chance server location, like let's say that, so like this, like servers, chance servers from the servers. I've been put chance server. Yeah, this is probably it because server go path and also okay. This makes sense. Yeah, this makes sense. So it relies on other services. I don't think it's mentioned anywhere in this diagram. But there should be like how do master knows which server is there, which chance server is available. It must be stored somewhere. Like if a minute, wait a minute, John and spaces John location. So this will be if like given Chong dies and given Chong server dies, like how do the master can tell, like say the Chong dies. Okay, so I need to update this, right, from the background process. Okay, hey, do you still have this? Probably like this, for example, the rate duplicate or the Chong server herbit. Hey, do you still have this full replica for this chunk. Okay, still there exists. Okay, good. And it's not, hey, I do not have this part. Okay, go to that replica. Or maybe like, okay, I do not have this. Okay, that replica is gone. So I have to re-replicate this part of the chunk to there and like update the metadata where the where the location is. But the replica is not stored anywhere. Oh, okay, I got confused with this. Got confused. If it does not store the chunk server location, and it's going to probe that at the startup. So how do the master? How does the master can tell where is each chunk location? Yeah, this is quite it's missing in the paper. Like maybe in the later chapter, but I just trying to make it make sense up until now. But yeah, I think there's some intuition. Oh wow, it's still a lot. Data flow. I just reviewing the abstract there, and it's really giving me a lot of questions. So I will try to write down this like question. If like question for this is that question if all made if the chunk location probably it should be there. If the chunk location is probed at start of time, then how does the master can tell can have a persistent view of given file and its chunk. If the chunk server in I mean sorry, like because it is persisted, right? So how does it mean that when this get all chunk server, it's not like just getting the chunk server, but like also getting all of the possible files exist? So then what's the purpose of the chunk server? To store this, okay, to store this information. So it's just like this being a broker, like instead of sensor control plane. It does not store anything. Does it mean yeah, or how does it synchronize with local log? I'm trying to synchronize. It's easy, but like synchronize, but which one to trust? I think at the startup, it probes every chance server. Okay, the chance server is going to return, hey, this is my address, and this is the list of the chunk that I have, and for this file, right? And this is my location, and it's and each of these chunk stored the replica in here and there, right? Okay, that makes sense. But okay, and then I have this file, right? I have this chunk to master probe response, but then how do I like consolidate with the one that I have in metadata store in this one? Like, what if the chunk location is gone? Okay, wait, this one, the chunk location is not stored. in memory. This is stored in memory, but this is not stored in persistent store. Okay, like it's quite like it's gonna make sense, but and so it has a file name. So it's going to match the channel list and the file name, and it's going to populate the channel location. Okay, that's okay, but then how does it like no, okay, so at the start of like you did that, okay, did the probing, but I'll just make sure that it is being replicated properly. Okay, because it is based on the assumption that 3 replicas, even if one goes bad, then you still have 2. And like when it probes, okay, get the out from the DNS surface, get the channel cipher. Okay, for this file, it is stored in 2 replicas, then one is gone, then I need to re-replicate it. Probably that kind of process. Probably. Okay, that's kind of makes sense. Okay. That's okay, that's kind of makes sense. All right, so yeah, we are at here. Quite long, since cool. Okay, I just like read one like three paragraph to like trying to understand this. It's almost like an hour. But yeah, I will take a break and like we'll continue later. See you later.